Hi, everyone. Welcome to our reliability celebration. Hello, Andre, Andy, Chester, Chris, Dennis, Ivan, Jeff. Hi, Jeff. Joseph, Karen, Kevin. Wow, we have a ton of people on today. I'm super excited. Thank you for joining me. Could you just put in the chat if you can hear me, just to make sure? Hello, Simon. Hello, Havinda. Just put something in the chat that, oh, yes, you can hear me. Okay, all right. So we are going to get right to it because I promised you a celebration, and we are right in time for the landscaper to be here also. So luck is definitely on our side today. Now, what would a celebration be without balloons? We are celebrating a very important birthday today, and we're going to get to that in just a second, but let's just take care of some quick housekeeping things. So we're going to be on together for 45 minutes or so. If we have lots of questions, maybe we'll go a little bit longer, but you can feel free to ask questions. And in that vein, let me share my screen. I promised you, okay, so here, the first thing is if you're joining on Zoom, and this is not a PowerPoint slide, this is a PDF. I just want to point out, if you look down here at the controls, there's chat, which many of you have found. So you can just click on this button and then this window will open for you. And you can either send a chat just to me, or you can send it to everyone just by clicking that button. And I think you can even be anonymous if you want. Now, the other thing is if you have any questions, you can click on this Q&A button and this will pop up, and you can be anonymous if you want. If you don't want for anyone to know who's asking the questions, just click that button and I'll stop in between to answer your questions. Okay, so the other thing is I promised you no PowerPoint slides because nobody brings PowerPoint to a party, and we're going to have, I guess, as fun of a party without adult beverages as we can today together. So, all right, let's get to it. We're going to get a little serious. I'm going to take off my hat. And, oh, good, you can see and hear me. Hello, yes. Hello, Ivan. Okay, awesome sauce. We are here today to celebrate, I would say, of course I'm biased, but I would say it's probably the most important maintenance and reliability milestone that there is, because today is the 52nd birthday of, I'm going to hold it up to the camera to make sure you can see it, of MSG1. And look, I wasn't kidding. July 10th, 1968. Now, maintenance and reliability, it just lights me up in general, but something else that really gets me excited is that my favorite month of the year is July, and my birthday is in July, and I know a lady never tells her age, but for reliability, I'll do it. I share the same birth year as MSG1. So that makes me just feel, I don't know, maybe a little more connected. So there you go. So this document, first, let's talk about why it's so important. But before we do, we have to talk about how it even came into existence and why, because it is super, super important to us as equipment custodians, as responsible custodians. It's very important to understand why all of this came about, because if you don't understand it, then you may not be taking care of your equipment properly. And then you end up being at the mercy of your equipment instead of you controlling your equipment. So the story takes us back to the mid-1950s. I promised you no PowerPoint. The mid-1950s in the commercial airline industry. Now, at that time, things were airplanes were pretty simple. And the thing is their philosophy at the time is that they believed that most failures occurred because of age. And their maintenance plans reflected this philosophy. They were very high in scheduled overhauls and very high in scheduled replacements. So, okay, but now time starts to march on, right? And now we find ourselves in the early 1960s. And what happened at this time is we see the emergence of newer aircraft with more complex systems like hydraulics, electronics, pneumatics, pressurized cabins, and turboprop engines. So it's brand new equipment. They don't have any experience with a lot of it, but yet they have to come up with a maintenance plan for it. So what they did is, if this was their maintenance plan, what they did is they mirrored it and they just copied what they had. And in the case where they didn't have anything to copy, well, they just took their best technical guess and they put the maintenance plans into existence, into service. And what happened is the crash rate started to increase. So now they say, oh, brother, we got it wrong, right? So based upon their philosophy at the time, now remember what the philosophy that they believed at the time, if this axis is age, and this axis is the conditional probability of failure, basically what they believed is you install a new component, and after a certain amount of time, if you don't overhaul or replace, then it's going to fail. So they believed if they intervene, like for example, with their piston engines, they were overhauling them every 6,000 hours. So when this happened, what they did is, they was consistent with their philosophy at the time. They moved their overhaul and replacement intervals back. And in the case of the piston engines, they moved it back to 4,000 hours. And they put these maintenance plans into service, and things started to get worse. So it was a huge problem at that time, as you can imagine, if the crash rate is increasing like it is. So it was actually United Airlines who first stepped in and said, we got to do something about this. And they embarked on an enormous amount of research. And what they found literally rocked the world of maintenance at the time, because they figured out that only 2% of failure causes were actually behaving according to this curve. And what they proved with their research, and they did research on electronics, hydraulics, pneumatics, structures, and engines. And what they figured out that is essentially 89% of failure causes occurred randomly. So now, what do? I mean, suppose this is you, and you are the custodian in charge of these airplanes. I mean, what do you do now? Well, at the time, there were some pioneers in our industry. There are many of them. Two of them were Stanley Nolan and Howard Heap. And they took a step back and they said, okay, we've assumed two things, right? We assumed that this was the way failure behaved. And we already tried moving the intervals back and that didn't work. So they realized they needed a new way of doing business. And that is what gave rise to MSG1. So when you go through this document, I'll spare you, right? Because as you can see, I've gone through it because I told you, I mean, this stuff really lights me up. And just one thing, let me point out one thing. Look at the, just look at the font and the text, because it's totally obvious that someone typed this. And I think that is really super cool. But when you read through this document, this was the first step in how reliability-centered maintenance evolved. Now, I'm not going to give you like a whole lesson on RCM today, because that's not our purpose. Our purpose is to, number one, celebrate, but more importantly, number two, identify how it is that all of this is still relevant and how it can help us solve. And from what I have observed in my career as the biggest reliability problem. That's what we are going to do today. So the thing is that this gave rise to a philosophy. Now, why is that important? Why is our philosophy important when it comes to equipment? Well, let's take a look. The first thing I want to do is let's take a look at reliability first, right? Now, I'm like a basics kind of a girl. I'm a simple person, right? You could ask a ton of people what is reliability, and you could get a ton of different answers, right? We could put equations. I have a glass whiteboard here, which I love. We could write all sorts of equations. We could get very theoretical, and all of that stuff. There is a place for that in our industry, but it's first very important to understand the basics. Okay, so what is reliability? Here's what my mentor John Mowbray taught me about reliability. He said that reliability isn't a thing on its own, but rather it is sprinkled amongst all of the functions of a piece of equipment. So what that means to me in my basic mind, and what John taught me, is what that means is if your compressor gives you what you need, if it runs when you need it to run, and the output is what you need, then that's reliability. Then that means you have a reliable compressor. So really what it means is we as equipment custodians have to figure out how to get that kind of reliability we need. Now, here's the thing. See, we may not consciously realize it, but we design our reliability. And I'm not talking about just literally, because yes, literally, we design our equipment. I mean, we design our reliability, right? It's inherent reliability. Well, inherent reliability doesn't mean how long something is going to last without failing. Inherent reliability means the kind of reliability that we get from our equipment when we protect it with the right proactive maintenance and some certain default strategies. Okay, so yes, design, definitely. I mean, if you buy a compressor that won't give you the output that you need, it doesn't matter how much maintenance you do, right? So you can never get more out of a machine than it was designed. We all know that, right? But here's the other thing, and this is what really lights me up. And this is where I think, especially in today's world, we have to focus. See, we figuratively, how am I doing with no PowerPoint slides? If you like it, give me like a yes in the chat or something like that. Okay, so we also figuratively design our reliability, right? Because yes, we do maintenance on our equipment, but there's a whole lot of other stuff, right? I mean, we've got training programs, we've got operating procedures. I mean, we have protective devices that we have to take care of, like pressure safety valves, for example, that we need to take care of properly. We have, oh my gosh, there are supply issues. And let's not forget the human element, which we're going to come to almost before we're done. The human element, which you hear a lot today about a reliability culture, which I think that's actually becoming more important than anything. So anyway, all right, so here is reliability, right? So we design it both literally and figuratively. But here's the thing. This is the most important part about today, is that how all of these are all conscious choices and conscious decisions that we make as equipment custodians, right? So we either choose just not to really pay attention too much, or we systematically and logically assign these kinds of things. What that is, I'm running out of room here. Here's the word. it all comes down to philosophy, right? So now I'm going to tell you a story. And I'm going to come clean. For those of you who maybe don't know, I love no limit Texas Hold'em poker, and I play tournaments, not cash. And my heart is bleeding for, well, my heart bleeds for our world in general, of course, but my heart bleeds for Las Vegas because they're heavy hit for so many reasons. But I miss being around a live poker table. And I miss people too. So I can't wait for all of this stuff to be gone so we can all assemble again. I haven't hugged anyone but my husband in months, and I'm of Italian descent, so I need to be hugging. Okay, so now I've gotten off track. So let me get back on track. So I'm in Tunica, Mississippi, and this is several years ago, and I'm playing in a poker tournament. And I'm not really thinking about much of it. You know, I mean, I just play poker to have fun. And I look up at the tournament clock and there's like 30 people left. And, you know, then I look up and there's 20 people left. And then I look up and all of a sudden there's 10 people left, which means I made the final table. And then before I even know it, there were 2 people left and I'm one of them. Now, I had been playing really well up until that point, but I'm going to come clean and I'm going to tell you, like, I think a human being's most dangerous enemy in the world is that 4-letter word that starts with an F, and it's fear. I let fear get to me and I started to play horribly, right? And my opponent picked up on it and he started to exploit me. And all of a sudden, he's got 80% of the chips in play in front of him. Now, luckily for me, a scheduled break came up. So my husband takes me aside and he says, "What are you doing? You're letting him steamroll you." And I mean, you know that feeling when your stomach just sinks? I'm thinking, oh my gosh, he is so right. I just felt sick. So I went into the bathroom and I locked myself in a stall. And I actually have a talk with myself, right? You know what you need to do. You know what you need to do to win. Just go out there and do it. So I look at my watch and I've got like 8 minutes left. And so I put my headphones in and I listen to a little bit of Vanilla Ice to kind of get me in the groove. And then I go back and I sit down at the table and I make a few timely bluffs. I fold when I know I'm beat. And I call when I know I have the best hand. And in 30 minutes, I won that tournament. Now, my question to you would be, you know, why? What was the difference between me here before the tournament versus after the tournament? And it was my philosophy, right? So my philosophy was making me make all these bad moves, but I changed my philosophy because I know what the right thing is to do. And that's how philosophy is so important and in reliability. And that is why MSG3 is, in my opinion, the biggest milestone when it comes to maintenance and reliability, because out of this document, and all of it is in here. I mean, I've got all these sticky notes. Like I said before, I'll spare you. But all of the stuff that is embodied in it is the stuff that most all of us have heard about, right? Like, oh, that's a red pen. I always lose my markers. Okay, like, how about FMEA, failure modes and effects analysis? Another term you read in there is optimized maintenance. It talks about, you see, I'm going to show you in a second. It talks about decision logic trees. It talks about on condition maintenance. That's the term that they use. Oftentimes in our industry, a lot of people say condition-based maintenance or predictive maintenance. And a lot of people say that all those 3 terms mean something different. And I mean, okay, but again, like, I'm a basics girl. So basically it means, you know, you do maintenance when you need to. So these are just a few of the things that you find in the MSG report that has now come to life, which is what we know of as reliability centered maintenance. Will you put in the chat if you can still hear me? Because I heard my computer bleep. I want to make sure you can still hear and see me. Yes. Okay. Thank you, Sarah. Thank you, Simon. Yes. Thank you, Igor. Okay. All right. So here's the thing. When it comes to people and when it comes to machines, it's kind of like the same thing. So if I came to you and I needed to learn something, or if I came to you and we needed to collaborate on a project, and I speak English and all you speak is Greek, we are not going to get anywhere, right? I mean, we're just going to sit in the room and I won't have any idea what you're talking about. So I'll just end up and go back doing my own thing. Now, this leads me to what I believe to be the biggest problem in reliability, and that is, you want to put in the chat if, I don't know, maybe you could put what you think. I don't have any data to back this up. It's just from what I hear from people. But if you want to put something in the chat, go ahead, and I'm going to write down what I think it is. I'm making sure. Just also let me know if you can still see me. Okay. Here's what I think it is. People today, organizations today, that is, are in reactive mode. So it's kind of like, and it happens in our personal lives too, right? Everyone is so busy running from fire to fire that there doesn't seem to be time to stop and take a breath and get proactive. And I think another reason why is because getting proactive, it takes work and it takes time. Now, I want to share something with you because we can look to nature for the answer. And I'm just looking. Nope. Hold on, I'm getting it. By the way, this is my very first live, so that's why I keep saying, let me know if you can hear me. Okay, so let me share my screen now. I don't think I'm sharing. See, we've got infant mortality going on here. We'll talk about that in 1 second. Share screen. Oh, come on, why won't it let me share? I totally practiced this ahead of time. Rats. I'm gonna try one more time. Why won't it let me? Oh, you rat. Need to understand why the day needed to be saved. Make sure you are the host. Okay, you can hear me. Oh, yeah, I know. I'm definitely the host. I know I'm the host. And I totally practiced this morning. Rats, I have a video I want to show you. Okay, here we go. I think I found it. Well, now you're seeing the PDF now. Rats. Okay, well, that's just not going to work. So I'm just going to tell you what it was, but it's really cool. I had nesting robins outside my kitchen window. And when as they started to grow up, you know, the mother would go, and I have a video clip of this. I wish I could get it to work, but anyway, that's okay. So the mother would come back with a bunch of worms in her mouth, and, you know, it's almost like she's shoving them down the throat of the babies, but they are just so delighted to be eating it. And the mother bird just waits. And the baby is like doing this with his mouth because he just wants more worms. But the mother bird is just stepping back and she's just waiting because she knows what's going to happen. And on the video clip, you wait like 12 seconds. And then all of a sudden, I had it in slow motion too. The little bird, the baby bird kind of picks up its butt and it poops. And the mother eats the poop. Now, I know this is totally gross, but it's nature. And it's germane to what we're talking about. So she eats the poop. And one of the reasons that she eats the poop is that so that it doesn't build up in the nest and get really stinky, because then predators smell it and then they'll eat the babies. So the reason why this resonates with me when it comes to maintenance and reliability is one of the things that was born in MSG1 was a FMEA. Now, they don't mention functions, but they talk about failure modes. So failure modes and effects analysis, right? So another thing that my mentor taught me is that we manage our physical assets at the failure cause level. When I say failure mode, I mean the same thing as a failure cause. What specifically would cause failure? So he taught me that we manage physical assets at the failure cause level. Now that bird knows it because, you know, she doesn't just kind of hang out, you know, give them the worms and wait 3 days and then like carry all the poop away after 3 days. She knows she has to keep up with it because if she lets it build up, they're gonna eat her birds. And that's what happens to us with our machines. When we don't stop and properly take care of our equipment, figure out what it needs from us, so it will keep doing what it needs. If we don't stop doing that, then we end up in reactive mode. We're running from fire to fire. And in my opinion, I think what is even worse is we've got frazzled teams, right? So maintenance is annoyed at production because production is yelling at maintenance and production is saying, why won't my machines work? And, you know, management is like, why are the machines down? I'm losing money by the hour, right? Yes, taking care of the golden goose. Stephen Covey, amazing analogy. Oh, thank you for that. It was like a gift. It was like a gift from the universe that these birds were out there. Okay, so anyway, it comes back to our philosophy. So how we decide to take care of our equipment is where it all is. So what started, for example, let's just take condition-based maintenance, for example. So a lot of times in, you know, well, before all this world mess, when I would present at conferences, you know, I talk about condition-based maintenance and I talk about the P2F interval. Now, a lot of people in our industry have not heard about this concept. And I don't mean this, and I don't say it to be like mean or judgmental. Because it's a problem that people still don't know about this. But this was started, at least the first known documentation that I've come across personally. You know, this is back from the 1960s, right? So here's the P2F interval. So the x-axis is age, and age could be calculated in any number of units. It could be calendar time, cycles, operating hours. It could be any number of things. It doesn't just necessarily mean time. And this axis is resistance to failure. So in the curve, generally, we can get more advanced, but generally it looks like this, right? So at this point, you've got F, and it's up to you to define what you think of as failure. But let's just take a very simple example. And let's say we've got a V-belt, right? So we know that a V-belt wears over time. And eventually, if we were to look, we would see evidence like cuts and frays, right? This is known as a potential failure condition, meaning, you know, it's got the potential of failing if we don't intervene. So from the time that those cuts and frays are visible to the time that it actually fails, well, this interval is called the P2F interval. So how often we do a CBM task depends entirely on this P2F interval. And what John Mowbray taught me, the way he used to say it, is when you do condition-based maintenance, it has nothing to do with I'm sorry, I got distracted by a chat. It has nothing to do with how often failure occurs. It has everything to do with how quickly it fails, right? Because a belt might last for 2 years, but it may only be 3 months from the time you can see phrase to the time that the belt actually breaks, right? Here, belt breaks. So that means you're going to have to do your inspection at intervals less than this 3 months, or else you're going to miss the failure. So this is like super important. And this is the heart and soul of condition-based maintenance, right? Now you can do CBM with the human senses. You could just go listen to it. You could go listen to a machine. You know, you could feel for heat. You can use more sophisticated devices. And now we're seeing the emergence of, industrial Internet of Things and prescriptive maintenance, where you outfit your machines with senses, and then based upon the data, it'll spit out a work order when you have to like change a bearing or something. And all that is great. But if you don't have this foundation, if you don't have this language down, then all that other stuff is just a shiny object. Okay, I got to get a prop. I'll be right back. We got to pause for shiny object syndrome. So I've worked with a lot of organizations where their first step in implementing CBM was to buy the monitoring equipment and outfit it. But you know, what happens oftentimes is you end up collecting data that you just don't quite know what to do with. And I fell prey to it myself. Okay, so this is called the Smooth. And it's like you put your smartphone in it, and it's supposed to follow your eyes when you're doing a video. So I don't know if you follow me on LinkedIn, I do a lot of videos. So I bought this thing thinking I'm going to be it when it comes to videos, and I'm going to walk around. They showed people on skateboards and everything. Well, let me tell you something. I have an engineering degree, and I could not figure this thing out. I paid $150 for it, and now it's a prop for presentations. But the point I want to make here is, what is most important when I make a video is that I have a cogent thought, that I present a problem, or I identify a problem, and I explain a possible solution. That's what's most important. If I don't have that, then this doesn't matter. And when we don't know the fundamentals, when we don't understand the language of reliability, then it's just all a waste of time and a waste of money. And then I think we end up getting frustrated, and then we don't do anything. And so back to the bird. The other thing about the bird is, you know, she made her nest, she laid the eggs, and then every day she was there, keeping them warm. When they hatched, she took care of them, she fed them, she carried the poop away. It was work. So the other thing I think and it's not just in our industry, in our world today, you know, if you want to talk to someone, you text them. I mean, email is almost becoming archaic, right? You text them, instant message them, or whatever, but you get the answer right away. So I think in our culture, we're used to getting what we want and what we need very quickly. And when it comes to reliability, it takes time and it takes work. But when you know the right things to do and the right way to implement things, you know, you take baby steps. Momentum, here's another thing. Dr. Seuss said that you never know the value of a moment until it becomes a memory. And I remember sitting in PS 101 in physics class in college. And I remember the lesson of the day was momentum. And I remember the instructor saying, momentum is equal to mass times velocity. But velocity, this is what I, for some reason, I don't know, I just very vividly remember this lesson, that velocity is not just speed. Velocity is speed and a vector. So it depends on your, meaning it has direction. So if you're doing the wrong thing over and over and you're doing a lot of it, well, then you're going to be in reactive mode. So you have to, number one, make sure you're going in the right direction, and you have to take action. But the key is to start off slowly. and build your momentum and not think that you have to all of a sudden like implement an entire RCM program or implement, condition-based maintenance across your entire plant or your entire organization or your airplane or whatever it is that you're taking care of. Okay, let me show you. Okay, first I'm going to show you here because this is something in this report that is super cool. So if you see this page, this is like, and again, there may be other things out there, but this is the first place that I've seen it documented. It's like the beginnings of a decision diagram for maintenance and some other default strategies. Can you just put in the chat if you can still hear and see me and everything's good to go? I don't want to be blabbering on and yep. Okay, thank you. All good to go. Thank you, Kevin. Thank you, Loic. Thank you, Chester. Hi, Chester. Thank you, Johan. Thank you, Havinda. Thank you. Okay, so this is super cool. It's the beginnings of the decision diagram. So this, it says decision diagram to assess desirability of maintenance tasks with potential effectiveness, right? Does the failure mode have a direct adverse effect upon airworthiness? Now this started in the airline industry, but hold on. Let's just pause right here because I hear often, oh, we don't want to do RCM because that's for airplanes. It started in the airline industry. Well, I mean, first of all, it says in the first RCM book written by Nolan and Heath that they wrote the book so that it would be used all over industry. But the other thing is if you look at an airplane, what's on it? Electronics, hydraulics, pneumatics, structures, engines. I mean, you find all of that stuff in every industry. It's just used differently. Okay, so then we come here, let's see, is reduction in failure resistance detectable? Do you know what they're talking about? Is the detection, can you detect failure resistance? This is what they're talking about. This is the resistance to failure. So this is exactly what they were talking about. And what they were onto was optimizing maintenance. And you find that verbiage in this report. Now I'm going to share. Now this I know I can share because it's not a video. Okay, so this is, okay, I'm sharing now. This is like a bare bones RCM decision diagram, right? And I'm not going to go through the whole thing, but I want to make a point about it. When you hear people say, oh, well, I need to optimize maintenance, right? All that means is this, because remember, look, I'm a basics person, I got to get it down so I can understand it in my brain. What it means is it technically the right thing to do? For example, how often do you change the alternator in your car? I mean, we don't change it on a scheduled basis. And that's because technically it's not the right thing to do because it's a random failure, right? Today, my alternator, generally speaking, I know we could maybe talk about brushes and get detailed, but generally speaking, it has the same chance of failing today that it does next week. So why would I change it today if it fails randomly? So number one, is it technically the right thing to do? And number two, is it worth it? And all that means is if I identify technically the right thing to do, like, for example, change my engine oil every 7,500 hours, is it worth it? Well, let's just do a quick thing. If I never change the oil and I just keep driving, my engine components are not going to be lubricated properly. It's going to cause abnormal wear and premature failure. And I'm going to have, I mean, it's a ton of money in engine damage, right? As opposed to every 7,500 miles, I personally bring it to Subaru and I pay, I don't know how much, 30, 40, whatever it is, $40, and I change the oil. Now we could do a calculation over time, right? Let's say I keep my car for 10 years. We could do a calculation, but we don't even need to for this. This one's like a no-brainer. Obviously, I am going to change my oil because it's technically the right thing to do and it's worth it. That's what optimizing maintenance does. Now, when it comes to reliability-centered maintenance, for example, which was born of MSG1, this is a basic decision diagram, right? You put each failure cause, it's like a funnel, right? Hold on, I gotta get another prop. It's like this, it's like a funnel. The RCM decision diagram is like a funnel. You put each failure mode in, and then like software doesn't decide this for you. What comes out of it is an optimized maintenance program. So first you consider condition-based maintenance, you consider scheduled restorations or overhauls, replacements, and maybe even if you assign maintenance, maybe there's a default strategy you might need to do. Like maybe you stumble upon there's an error in a tech manual or something. That's what optimizing maintenance is all about. See, all this stuff, let's see, when I first started doing reliability-centered maintenance when I was an employee of the US Navy. And we collaborated with the Royal Navy's RCM program. So we didn't really work together, but we met every, I don't know, 6 months or so and spoke at conferences together and collaborated so that we could learn from each other. And I was at dinner one night, our team dinner in Bath, England, and Commander Andrew Matters, he was the head of the Royal Navy's RCM program at the time. I'll never forget this. He leaned in and he said, you know, Nancy, RCM is nothing more than common sense applied to physical assets. And I never forgot that, because that's really what it is. It's common sense applied to physical assets, but it takes time to do. And the other thing that's super important, and it's in the MSG1 report, they talk about working groups. So another important thing that you can do really with any improvement effort is to get the right people involved, right? Like operators and the operator, the maintainer, the engineer, get them in the room at the same time, talking about things and making decisions on their equipment. But beforehand, you have to make sure they speak the same language. So everyone has to understand P2F curve, P2F interval, functions, scheduled restoration, inherent reliability, probability of failure, conditional probability of failure. Once you get everyone on the same page, it's so much easier. It's so much easier, and just magic happens when you bring your team together. And that goes a long way to developing a good reliability culture. So I want to pause for a second and if you have any questions, you can either put it in, yes, I'll share the PDF. Yes, Loic. Was it not? Yes, it was. Okay, so RCM was not the question. The question from Derek is, was it not military that started RCM? No, it wasn't the military that started it. It started in the commercial airline industry, but in the early 70s, the United States Naval Air Systems Command, they were interested in knowing how the commercial airline industry was coming up with their proactive maintenance programs. So they commissioned Nolan and Heap to write a report on what they were doing. And they wrote their report, and it was published on December 29th, 1978, and they called their book Reliability-Centered Maintenance. Now, because it was commissioned by the United States government, it's in the public domain. So that's why all of this stuff, you see different flavors of reliability-centered maintenance, et cetera. Because the government commissioned it, it's in the public domain. So that's how the government got involved there. So let's see, I'm gonna pause now, because the other thing is I'm Italian, so I get going with talking. So let me know what questions you have. Okay, how do we determine the P2F interval if we don't have historical data to work from? Yes, I love this question. And the number one, okay, so first of all, I personally have never worked with an organization that had a ton of data that you could use to determine P2F intervals, because we're not talking about how often something fails. We're not talking about an MTBF. We're talking about how quickly it fails once a potential failure condition is detectable. Now, if you're using human senses, The people, like, this is another reason why you get the equipment experts involved. The equipment experts, when they're asked the right questions, they're super clued in on this stuff. They can answer a lot of these questions. So one answer to that question is people. You're the people who know the operating environment and they know the equipment. Now, if you're going to do something like, if you're going to lubricate based on ultrasound results or vibration analysis, the people selling those devices, if you find the right one, they have techniques to help you figure out what that P2F interval is. But here's the but. Before you go off and buy equipment, you want to make sure you identify what that failure cause is, so you know what it is you're trying to manage, and then you go from there. So I wish I had like the simple super answer, just go to this database and you'll find all the P2F intervals, but we live in the real world, so it just doesn't work that way. So equipment experts and yeah, figuring it out with people who know. Let's see. Okay, where does RCD stop and RCM begin? Is it at the FMEA or the FMICA? Okay, this is a really interesting question, because in here, they don't call it reliability centered design, but actually MSG1, and right now they're on, it's MSG3 version, I don't know, I forget what, but they've stopped at MSG3 and they just keep upping the versions. In that document, it clearly states that that process is used to identify maintenance for prior to service aircraft. So one reason why this document was created was to intervene at the design stage, so that you could, design for, you hear like design for reliability. And I mean, it's an excellent idea, because how often do we procure something and then we put it in the field and it doesn't do what we need it to do anymore? I mean, it happens all the time. So it's important also to get a working group together before you do procure something. But my answer to that is, I mean, I don't know. I think that the line between reliability centered design and reliability centered maintenance, I think that they're really close together, because if you're doing RCD, the first thing you're going to do is identify functions, what you need it to do, right? Now, I'm not talking about what it is, right? Like how much horsepower you need and, all the technical details. It's about identifying what you need, so you make sure you design according to what you need or purchase according to what you need. So my answer is to do RCM as early in the design stage, as early in the asset life cycle as possible. And, a lot of people call it RCD, and, that's fine. Because at that time, you're really just going through a FMEA, right? It's a design FMEA. You're identifying functions, and then you come up with a design, and then you identify, well, based upon this design, what would cause me not to get what I want? And that gives you a systematic way to think about, okay, then I'm going to make this design change before I even build it. Okay. Failure truly random. Is it not the case that we just can't detect the failure early enough? I mean, nature knows when and why something fails. Okay. Yeah. Another excellent point. I mean, sometimes we can't detect the failure early enough. Maybe we don't have the capability of even identifying this, or maybe it's too quickly. Maybe the P2F interval goes too quickly to even matter. And this brings us to something else that I was taught, that John Mowbray taught me. And that is the essence of reliability-centered maintenance, which could be the essence of RCD also. This is the essence of what we do as responsible custodians. The essence of reliability-centered maintenance is managing the consequences of failure. So if we have a failure mode and we want to do CBM on it, but we have identified that our P2F interval is too fast for us to do anything before that failure occurs, then what we need to do is change the consequences of that failure mode or failure cause. And that could be putting in redundancy. It could be, buying a more robust machine. It could be putting a protective device in place, maybe emergency procedures. And this verbiage, managing consequences, that verbiage is in this document. So it's all this stuff that you hear, FMEA and all this stuff. All of this is over 50 years old. And I mean, my thing is RCM, that's my area of expertise. And I did not come up with RCM. I didn't come up with any of this stuff. I've just spent the last 20 years trying to master it. And I keep learning every day. We all do, right? But that's the point, is that this stuff has been around long enough that we need to teach our teams this philosophy. Because when everyone gets on the same page, it's the answer for getting out of reactive mode. And that's the answer for, I'm gonna ask you to answer a couple of questions for me before we leave. But I have an idea for my next live, if anyone would be interested in it. And it's the answer to this question: is maintenance a cost center or a profit center? And I have what I believe to be the answer. But I don't want to digress on that. But the key is teaching everyone the language of reliability, understanding what it is in simple terms, and then working as a team to do what we need to do to get our machine to do what we need it to do. That's it. Okay, let's see. What is the best tool software to execute a good RCM study? Okay, yes, Fabio, I have some ideas on that, which I can share with you. If anyone else would like that, you can email me. I'll give you my email address at the end. I do not sell software, but I know of some programs that I could recommend. But the one thing I do want to make sure is that when it comes to RCM, do not start with the software. Start with learning the philosophy, doing a pilot project or two, getting your team spooled up on what it means, and, doing an analysis so that you can figure out what it takes to do RCM and to make sure you're getting the results that you need from it. And that brings me up, that gives me one more thought. Will you put in the chat, just say like, yes, or I'm gonna, let me see, let me read this. Okay, put in the chat if you've heard this. RCM takes way too long, it's way too expensive, and you don't get the results you need out of it. Reliability-centered maintenance. Put a yes if you've ever heard that. Yes, yes, no, yes, yes, from those who don't understand. That's it, Kevin. Okay, so here's the thing. I hear this all the time. It's too complex. Yes. Now, here's the deal. RCM is common sense applied to physical assets. If you sit down, let's say we're going to do a FMEA on our car. You could get down to the nut and bolt level, and you could end up with 1,000 failure modes, 500 failure modes. You can get so deep into the weeds that your failure causes that you're writing are too detailed. You can't make rational decisions. That's why if you're going to do RCM, you have to make sure you really understand it. You have a facilitator who understands it, because that person will lead a team into writing failure causes at the right level. That's the number one problem, that people use it wrongly. People think you have to write all failure modes. Well, no, you don't. You just identify those. You identify failure modes at a level at which you can identify an appropriate failure management strategy. But here's another thing. This is super important. And you know what? This goes for any improvement process, just about any improvement process, not just RCM. Because this live, really what I want to talk about this live is about reliability and how we bring our teams together and how we solve our problem about being reactive. Now, I mean, my thing is RCM, so I always default back to it. But here's the thing. Scope of analysis is everything. If you're going to do an analysis on a compressor or, I don't know, a hydraulic system on an airplane, whatever it is, you're in charge of the scope. You can eliminate some components within the system. You could say, I'm just going to analyze this hydraulic pump. Or you could say, I'm going to analyze the hydraulic system, but because of time and resources, I'm going to exclude the gauges, for example. See, it's all about what you identify your scope to be. Now, what drives your scope is the goal of your analysis. If you're designing something from scratch, you're probably going to get really detailed with your failure causes, maybe down to the nut and bolt level, maybe a little higher than that, but way more detailed than if you're going to do an analysis to come out with an optimized maintenance program, which is one of the products of an RCM analysis. Okay, so that's that. Let me see. There was another question up here about the military or the Navy. Hold on. Can we have aircraft and marine maintenance strategy, how they are doing RCM, CBM, TBM, FMEA? Okay, now, so here's another thing. So just to set the record straight, condition-based maintenance, let me just do this super quickly. RCM consists of 7 steps, right? Functions, functional failures, failure modes or failure causes, failure effects, failure consequences, proactive maintenance and intervals, and default strategies. Questions 1 through 4, this makes up your FMEA. If you do RCM the right way, you're doing a failure modes and effects analysis. You throw in question 5, failure consequences, you assess consequences of each failure cause. Now you've got your FMECA, your FMECA. And then you do proactive maintenance and default strategies. So I know that, within the United States Navy, they do traditional reliability centered maintenance. And then there are some other like shortened versions that they're doing. But I think, throughout industry, the other thing about why RCM gets a bad rap is sometimes people say they're doing RCM, but they're not really doing RCM. So that's another thing. One more point here. Another thing about RCM is people think it's just about maintenance. But in my experience, the gold, the big success stories that come out of it are the solutions that have nothing to do with maintenance. Because if you do RCM right, and you write your functions properly, and you have a team of equipment experts in the analysis, you're going to ask them questions, and they are going to be able to identify latent failures, like things where we often blame technicians. It was like human error. Human error was the problem, when really the interface was not user-friendly and it was just begging for a disaster, right? The people in the field know where the errors in technical manuals are. And I mean, I've heard it from them. I'll be facilitating and they'll say, oh, well, this is wrong in the tech manual, and that's why that failure keeps happening. And I'll say, well, why don't you bring this up? And sometimes they say, well, I have, and things never change. And sometimes they say, well, I know that people aren't going to listen to me anyway. So it comes all back to culture. But anyway, if you do RCM properly, you can end up with redesign changes to tech pubs, a whole host of other things here where you uncover gold. And another thing is, when you identify functions, sometimes you figure out that you're using the machine in ways it wasn't meant to be. Okay, let me see. There were some other questions. Yep. Every company I've seen using software, they never use it efficiently anyway. It's too powerful if you don't know what to do with it. Exactly. You got this thing that does all this stuff, but it really depends on the information that you put in, and then you don't use it effectively anyway. So Loic, 100%, I agree. The culture change is one of the biggest challenges. I agree. And I'm just going to start shouting it from the rooftops now. I think the number one problem is culture And I think the number one way to solve it is start getting people on the same page, with the philosophy. Because if production understood that if they shut down for a half a day, so this inspection could be done, then they don't have to be bothered with the machine breaking at a time where they didn't expect it. You see, but they're not thinking that way. Everyone is just running around in different directions. Okay. What do you think about RCM on this new era of Industry 4.0, online big data automation? I think that reliability-centered maintenance has never been more relevant because it takes us down from all of this shiny object stuff, right? IOT, the digital twin, prescriptive maintenance. Again, I don't want you to leave this celebration thinking that I think technology is awful. I don't. I wouldn't want to live without it, but it has to be implemented properly. And that begins with the basics. So I think it's ever more relevant. What is the last step? What is the last step after PM? It's default strategies. So other than condition-based maintenance or scheduled overhauls or replacements, you may need to take your pressure safety valves off maybe every year to make sure that they're not stuck, that they will relieve at the desired pressure in the event that the pressure rises above a certain pressure. That could be a default strategy. A default strategy could be to change a training manual. A default strategy could be to cut back on production because maybe you're asking the machine to do something it can't. You're overloading it, and that's what's causing it to fail. That could be a default strategy. A default strategy could be, we need to chunk this thing and just get something entirely new. That's step 7, and there's gold in that step. RCM is also a good training opportunity for staff. Absolutely. This is what I'm trying to figure out how to shout from the rooftops to make it make sense to people, is that the reason why I'm celebrating today is because this document, which turned into reliability-centered maintenance, this is literally a gift to us as responsible custodians, right? I mean, the crash rate was increasing at a drastic rate. I mean, it was safety related. So there were a lot of bad consequences that happened to give rise to this. So it's a gift that we should cherish, like we cherish our health, right? Okay, so here's the thing. If you want to be healthy, two things, you have to do a lot of things, but 2 things: you have to eat right and you have to exercise. Now, you don't have to go to the gym 7 days a week and lift 200 pounds. You could just walk 10,000 steps a day, something, right? But you can't just do nothing all year. And when December 18th comes, you go to the gym 24/7 for 3 days, and you eat 100 apples and 20 salads. It doesn't work that way. It's day by day, step by step, just like the mama bird was taking the poop away. But we have to make sure we don't ignore this gift, because that's what it is. So we have to start drawing our teams in and teaching them this philosophy. Okay. One big output is knowledge. Fabio, I 100% agree with you, because, oh my gosh. Okay, so I facilitated an analysis last year. And one of the guys in my team, who was a seasoned expert, he'd been there over 32 years. And I'm going to be honest with you. I thought I had in my head, because I'm a human being, right? And this is what we do. We have voices and all this nasty stuff that we have in our head. You're terrible. You're awful. You're doing a bad job. No one wants to listen, blah, 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 right? And you have to fight that. So I'm going to be honest with you. I thought this guy, because he didn't say too much during the analysis. He answered questions, but he didn't really express that he loved what was going on. So one day we were walking around the plant to answer some questions that we needed to fill some gaps into the analysis. And he said to me, or I said to him, I was scared to even ask. I said, so what do you think about this RCM thing? And he said, I've been doing this for 31 years. And I didn't realize how much I didn't know about this machine until we did this. Because when you sit down and write functions and then failure causes the right way, and then you write a failure effect, which is a story of what would happen if you did nothing to predict or prevent the failure cause, you have to tell that whole story. And another big cause of failure in reactive mode, sometimes organizations don't understand how equipment works. I mean, there are things in the field that have been there for 30, 40, 50 years, and they're still using them. So the people who knew about it, they leave, and then the process is not understood, or the machine is not understood. So another thing about an FMEA, when you do it right, is it captures that information. It's incredible. Where's the cake? I know, no joke, I was going to get a cake, and then I thought, I got a hat, I got balloons, they'll really think I've lost it if I get a cake. Next time, maybe. Okay. Can you tell us something on FFI? Yes. Very difficult to know protective devices, availability figures. How do we manage it? Okay. So this is, John Mowbray called it FIFI, failure finding interval. This is failure finding in a nutshell. So failure finding is associated with protective devices. Like, remember I told you, I gave you the example of the pressure safety valve, right? A pressure relief valve. That's a safety device. We never need it, right? It is to be capable of relieving pressure in the event that system pressure rises above, I don't know what, 400 PSI, right? So we never need it unless something else happens. That's why it's called a protective device. Well, in RCM, we have formulae that we use, and one of them is failure finding. This is just one. It's safety based, and it's assuming you just have one. N is one, which means like one safety valve as opposed to three, for example. One of the equations is 2, and I did not derive these equations. A brilliant man named Mark Horton, who has been so generous with his time and knowledge with me over the last 20 years, he derived all these. So if you want the derivation, I'm not your gal for that, but it's 2 times MTIV times MTED divided by MMF. Now I know I said to you, we can talk about equations, and I'm a basics girl, but we're going to break it down, right? And this is just one equation. There's a bunch of different equations depending upon what kind of a protective device that you actually have, okay? The gist of it is this: how often you check the failure finding interval, how often you check a protective device, like take the safety valve off, see if it relieves at the prescribed pressure. How often you do that is based upon 3 things, generally speaking. The MTBF of the device itself, the mean time between failure of the device itself, the mean time between failure of the protected function, which means how often would the pressure rise above 400 PSI, and MMF is how often you're willing to accept the multiple failure. So you put these 3 variables into this equation, and you come out with a failure finding interval. I don't know, maybe for example, 6 months. And then you check your valve at that interval. So what this equation is saying, it's not saying that your valve will always be available to you. It's saying that given your level of risk, if you check it this often, it will be available to you. But you can never say never. We live in the real world. So that's failure finding 101. This is another reason why you need a facilitator to help you to make sense out of all this stuff. Okay, let's see. And how do we, so that's how you manage it, William. I hope that helped. If you do a redesign on the machine, you have to recalculate the RPN, the risk priority number. Yeah, I mean, I suppose you would, yes. If you would have to do a new risk analysis if you redesign, for sure, yeah. How can we correlate RCM with criticality analysis? Okay, so Again, I'm a basics person, right? So when I think of a criticality analysis, I think of it, I mean, you can think of it in many ways, but just to break it down from a basic way, you can think of a criticality analysis at the asset level, right? You can say to yourself, how critical is this asset to my operation, right? But when you do RCM, you do a criticality analysis on each individual failure cause that you identify. That's the failure modes and effects analysis: functions, functional failures, failure causes or failure modes, and then failure effects, and then failure consequences. So let me share my screen. Let me show you. Right, so this is consequence assessment. So you put here's our funnel. You put your failure cause in the funnel. You decide what kind of consequences, in other words, how critical it is, and then you make your decision. Now, here's another thing: is someone mentioned risk priority number in the chat. You know, some people, when they do an RCM analysis, they assign a specific criticality to each failure cause. You can do it that way, or, you know, for most failure causes, you know, it's safety or operational. And then if you have a good solution for it, sometimes it may not be necessary to assign it. If you've got something super critical, right, a super critical failure cause, I've done analyses where it's been really critical. And one of our default strategies was to have engineering do a formal criticality analysis. Oh, thank you, Sarah. Thank you so much. Okay, there's no more in chat. Let me look at questions. Oh, okay. Where can you find MSG1 and MSG2? So MSG1, MSG2, and MSG3, they were generated what was then the Air Transport Authority. It's now Airlines for America. And I would share it with you if I could, but I wrote a letter like 15 years ago to the Air Transport Authority Association, and I requested copies, and I got a letter saying that it's copyrighted and that I wasn't allowed to make copies. So now it would be Airlines for America. You can write to them, and I mean, they gave me a copy. I don't see why they wouldn't give you one. Maintenance is a cost center that directly affects the profit center bottom line. Thank you, Joseph. Okay, that's going to be the subject of the next live. Yes, okay. All right, let's see. Are there any more? Let me see. That's the gist of what I had to share. Are there any more questions or thoughts? Because then we'll wrap up. And while we're wrapping up, let me share. I wish I could have shown you. Next time, I'm going to show you the video. Okay, so here, this is not a PowerPoint slide, it's a PDF. If you have any questions, this is my email. And if we're not connected on LinkedIn, this is my LinkedIn. I would be delighted with a connection request. And I can go live directly on YouTube if I have 1,000 subscribers, but I don't have 1,000 yet. So if you're a YouTube user, would you go to my YouTube channel and subscribe? So there you go. Those are those contact details. And now here, I have a favor to ask of you while you guys are getting in any last minute questions. I would like your advice. And so I'm going to post a link in a chat, and it's 3 questions. And one of them is, if you're not on my email list and you would like me to email you when I come up with new stuff, you can give me your name and your email address, and I'll add you to that. And I promise I don't spam, I don't sell, I wouldn't never sell your information. But let me put this in the chat. And if you would fill this out for me, I would be delighted. It's super quick. Okay, so the link is in the chat, and it's a Google Doc, and you do not have to log in, and you can be anonymous. So you don't even have to put your name. Okay, let's see. There's another question. What's the difference between MSG 1, 2, and 3? Okay, so really, thank you, because actually that's a point I wanted to make. So here's MSG 1, and this goes directly to how we achieve our goals of reliability. So you see here, the first one was July 10th, 1968. Revision 1 was August 1st, 1968. Revision 2 was June 1st, 1969. So all of this stuff, you know, planes were crashing, and it's not like they got their magic wand out and fixed it all just like that. It was a work in progress for them too. MSG2, that came out March 25th, 1970. And then MSG3 came out, oh, I should know the date by heart. It's 80 something. I'm having a total brain cramp. It was in the 80s. And so what are the differences amongst MSG 1, 2, and 3? Just progress. They just built on what they knew, they just built on the process. I mean, the MSG 1 report, I mean, this is their decision diagram, right? This is, and you saw the bare bones one that I put up. It's progress. And it's the same thing when it comes to reliability. You have to just take your time and be patient and make progress. You know, it's like today, if you want to lose weight or you want to be fit, if you start today and you really put the work in, next year, you're going to be a different person, but it's going to take a year. But that year is going to come. That year is going to come whether we like it or not. So the question is, how do you want to meet next year? What position do you want to be in? And I have one last thought, and I want to go back to the bird. I wish that next time I'm showing the video. So that's a reason for you to come back. Okay. The other thing is that I talked about the human element. Now, yes, it's all about teaching our teams the philosophy, but we are all human beings, and human beings are subject to fear. I call them the voices, comfort, getting too comfortable. I mean, sometimes reactive mode, that could be comfortable, right? Or you get up and you have something you want to do for the day, and you sit down and you're gonna do the presentation or write the white paper, and then you start with emails and phone calls, and before you know it, it's 3 o'clock and you've gotten nothing done. So comfort can be almost a little evil. Next time I'll share more about comfort, because we've been going long. I'll share it next time. But so the last thought with the poop is that as human beings, we've got poop coming into our head all the time, right? Because we live in the real world and not fantasy land. And in the real world, there is duality. There's positive and negative, right? There's dark and light, and there's good and bad, and there's sweet and there's savory. Well, every second of every day, we have to fight our most important asset, and that is our mind. Because we can either be thinking positively or negatively. They'll never listen to me. We'll never get the money to do that. Da, da, da. Well, if that's what you're thinking, I can guarantee you, you're never going to get the money, and they're never going to listen. So it's like the poop. You got to take that out, take that thought out, and replace it with, I'm going to keep working at this until I get the money. And I'm going to keep talking to them until they finally listen. We got to get on the same page. Anyway, that's my little flowery bit. So, okay. So thank you so very much, everyone. I am so sincerely delighted. If you could fill out that survey, that would be awesome. And let me just make sure that I didn't have anything else. Nope, I think that was it. So if you have any questions, you can just feel free to email me. And one of the survey questions was, would you be interested in another live? Because I would love to do more if people would be interested in it. So if you could give me that feedback too. So that's it. Be well, everyone. Thank you so much for attending. Happy birthday, MSG1. And remember to use the gift that was given to us 52 years ago. Goodbye, everyone. Everyone be well and be safe out there. Thank you.